Hey everybody, this is Miss Darty, and today I want to talk to you about hybridization. It's a very long word for a very easy problem. It's a complicated theory, but it is very easy to determine the hybridization of a molecule. So you should have this chart. It is on the bottom of your Vesper theory chart. Again, it's on the bottom of your Vesper theory chart. I highly recommend that you have printed out your Vesper theory chart. And so this is just on the bottom. Might as well save paper and just combine the two. If we were in class, I would give you that paper and you would have this on that paper. But anyway, this is at the bottom of your Vesper theory chart. So hybridization, the idea behind hybridization is that when atoms bond, they use their valence shells, and the octet rule states that they achieve 8 valence electrons and the electron configuration of the nearest noble gas. But with this hybridization theory, it says when atoms bond, they are going to change the shape of their valence shells and morph together their valence shells and form what we call hybrid orbitals. So if you think about electron configurations, if you had something like boron, for example, is a good example. Boron has the valence shell is the S and P sublevels. And if it bonds with a chlorine, the valence shell, the chlorine is the valence shell is the S and P sublevels. Well, they are going to morph those S and P sublevels together and form what we call hybrid orbitals. So that's the idea behind hybridization. And again, it's complicated, but all you need to know is how to determine the hybridization of a molecule, and that is very easy. All it is counting and matching. So what you're going to do is you are going to lump lone pairs and outer atoms together. And I just call that the number of things. So you're going to count the number of things. Again, lone pairs and outer atoms count as one each. It doesn't matter what they are, though. It just matters that they are there. So you count the number of things attached to the central atom. And all you have to do is match your number of things to the electron pairs column of your hybridization schemes chart. And then match your electron pairs to the hybrid orbitals column. So very literally, you are using this chart, you're counting the number of things which you match to this electron pairs column, and then you just match to the hybrid orbitals. Ignore the last column, that is electron pair geometry, and we are ignoring that column in the Vesper theory chart, so ignore that column in the hybridization schemes chart. So let's look at a few examples. And again, we're going to use the Lewis structure that we have and determine the hybridization here. So CCl4 has 4 things attached to it, which means that it is going to be sp3 according to your Vesper theory chart. See, 4 things means sp3. CH3Cl is the same, it's going to be sp3. NCl3. So you've got a lone pair, and that lone pair is going to not change the hybridization of your molecule. So you have 1 outer atom, 2 outer atoms, 3 outer atoms, and the lone pair makes 4 things. Which means that this is sp3. XEF5, you have 5 Fs and a lone pair, so this makes 6 things. And that means we have sp3d2. Let me check that. Yeah, 6 things, sp3d2. Okay, this we have 3 outer atoms plus the lone pair makes 4 things. Which means that this is sp3. You're going to have a lot of sp3s. Okay, CO2. We have 2 things on the central atom, which means that we are going to have sp. 2 things, hybrid orbital sp. O3, we have 1, 2, or the 2 outer atoms, and the lone pair makes 3 things. So this is going to be sp2. 3 things, sp2. Here we have, in the NO3, we have 3 things, which means that it is sp2. SiO2 has 2 things, which means that it is sp. Hybridization. OBR2, again, it doesn't matter what these things are, it just matters that they are there. So we have 2 BRs plus the 2 lone pairs makes 4 things. Which means that it is sp3. So another one where we have the C and then 3 O's, so this is 3 things. So that is SP2. And then last one. We have the 3 BRs, which is 3 things, plus the lone pair, which makes 4 things, which is going to be SP3. So that is hybridization for you. Thank you very much for learning with me today. I enjoyed learning with you.